Hi everyone, a warm welcome to the third part of complex integration by Cauchy's integral formula. I explained how to apply Cauchy's integral formula in part 1. So before watching this video, you have to watch the first video. Cauchy's integral formula is integral over c f z by z minus z naught dz equal to 2 pi I f of z naught. Here f z is an analytic function within and on a simple closed curve c, and z naught is a point within c. So for applying integral formula, we have to choose f z and z naught. Then for getting the value of the integral, you have to multiply f of z naught with 2 pi I. In certain questions, there is one and only one singularity within C. But in some other questions, you can see there may be more than one singularity within C. But we can apply this result only for exactly one singularity within C. So in those integrals in which more than one singularity within C, we must start with partial fraction. In this video, I am going to illustrate how to apply Cauchy's integral formula for the evaluation of complex integrals in which more than one singularity within C. Let me start it.
Consider the question. Evaluate integral over c 2z minus 1 by z square minus z dz where c is given by mod z equal to 3. First you consider the function and you find its singularities. Singularities by solving this equation, that is z into z minus 1 equal to 0. So the singularities are 0 and 1. So you have to factorize the given question, that is 2z minus 1 by z into z minus 1 dz. Next to identify the position of the singularities with respect to the given circle. So clearly 0 is inside and 1 also inside. Clearly both singularities are within C. See, the Cauchy's integral formula is integral over c f z by z minus z naught is equal to pi I f of z naught. In that formula, you can see there is only one point which lies within C and it is z naught. So for applying Cauchy's integral formula, here there should be one singularity which lies within C. Otherwise, we can't apply the Cauchy's integral formula directly. So here both singularities are within C. So we have to separate the denominator. Then you can easily apply Cauchy's integral formula. We can separate the denominator by applying partial fraction. How to keep in your mind, whenever more than one singular point which lies within C, you start with the partial fraction in all types of such questions. So here, first we have to give the partial fraction for 1 by z into z minus 1. Here the singularities are 0 and 1. Corresponding singular part in the given function is 1 by z into z minus 1. So you give the partial fraction for 1 by z into z minus 1. Partial fraction is a divided by z plus b by z minus 1. See, in these types of questions, we can find a and b by shortcut method. And the shortcut method is a can be obtained by. So for getting a, you look into its denominator. Its denominator is 0 when z equal to 0. You put z equal to 0 here. When z equal to 0, it is 1 by minus 1. That is minus 1. So a is minus 1. Similarly for getting b, its denominator is 0 when z equal to 1. You put z equal to 1 here. So it is 1. So this is the partial fraction of 1 by z into z minus 1. You apply the shortcut method. We have to evaluate this integral. For getting this integral, you have to multiply by 2z minus 1. So you multiply 2z minus 1 to the left side and right side. You can see it is minus of 2z minus 1 by z plus 2z minus 1 by z minus 1. You take integral on both sides. So right side is sum. We know integral of sum is sum of their integrals. So integral over c dz plus integral over c dz. You put this integral as I1, next integral as I2. So the given integral is now becomes I1 plus I2. That is equation number 1. If more than one singular point lies within C, you apply the partial fraction and split the integral. Then next you have to evaluate the integrals. Here you have to evaluate both I1 and I2. So for evaluating I1, you consider I1. I1 is integral over C. You take this negative inside. So you can see it is 1 minus 2z. It's not necessary. Here you have to choose z0 as 0. See, it is like z minus z0. And fz is 1 minus 2z. See, after converting the given integral into sub-integrals, you can see each integral can be answered by using Cauchy's integral formula. So in the integral formula, you have to choose z0 and fz. Then by Cauchy's integral formula, its answer is 2 pi I into f of z0. That is 2 pi I into f of 0. What is f0? F0 is, you put z equal to 0, it is 1. So into 1, that is 2 pi I. So we got I1 as 2 pi I. Next we have to evaluate I2. So consider the integral I2. I2 is integral over C 2z minus 1 by z minus 1 dz. You compare with this integral. So here we have to choose z0 as 1 and fz as 2z minus 1. So by Cauchy's integral formula, its answer is 2 pi I into f of z0. That is 2 pi I into f of 1. What is f1? f1 is, here you put z equal to 1. You can see it is 1. So the answer is 2 pi I. So we have I2 is also 2 pi I. You put I1, I2 in this equation number 1. So the answer is 4 pi I. So the value of the given integral is 4 pi. Next we have to answer another interesting question. And the question is integral over C sin pi z square plus cos pi z square by z minus 1 into z minus 3 dz, where C is mod z equal to pi. Here you have to keep pi as 3.14. See, in the given function, clearly the singularities are 1 and 3. Clearly, both are inside of C. See, we know if more than one singular point within C, first we start with the partial fraction. So we have to give the partial fraction of 1 by z minus 1 into z minus 3. And its partial fraction is a divided by z minus 1 plus b by z minus 3. Then how to get a? For getting a, you put z equal to 1 in this expression. When z equal to 1, it is 1 by minus 2, that is minus 1 by 2. For getting b, you put z equal to 3. You put z equal to 3, here you can see it is 1 by 2. So now we have the partial fraction of 1 by z minus 1 into z minus 3. Next you make the question. For getting the question, you have to multiply throughout by sin pi z square plus cos pi z square. Z minus 1, z minus 3 is equal to minus half into sin pi z square plus cos pi z square by z minus 1 plus half into sin pi z square plus cos pi z square by z minus 3. Next you take integral on both sides. So integral over C, you split the integral here, integral over C plus integral over C. Consider the first integral as I1, take the second one as I2. You put this as equation number 1. So for getting the value of this integral, we have to evaluate I1 and I2. Now we can find I1 and I2 with the help of Cauchy's integral formula. So next we have to find I1 and I2. Evaluation of I1. See, I1 is this integral. See, for a time Cauchy's integral formula, we have to choose z0 and fz. Then answer is given by 2 pi a into f of z0. Here, what is z0? So you compare this I1 with the Cauchy's integral formula. It's very clear. We have to choose z0 as 1 and fz as minus half into sin pi z square plus cos pi z square. Then by Cauchy's integral formula, I1 is given by, I1 is this integral. This integral is given by 2 pi I into f of z0. That is 2 pi I into f of 1. Next we have to find f of 1. F of 1 equal to, you put z equal to 1 in f is z. You can see it is minus half sin y plus cos y. When z is 1, sin y, it is cos y. What is sin y? 0. What is cos y? Minus 1. So answer is half. F1 is half, so the answer is I pi. So we have I1 equal to I pi. Next we have to find I2. See, I2 is this integral. We have to evaluate this integral with the help of Cauchy's integral formula. So clearly what is Z0? Z0 is 3. So Fz is half into sin pi z square plus cos pi z square. By Cauchy's integral formula, I2 is 2 pi I into f of z0, that is f3. Next we have to find f3. So what is f3? f3 is 1 by 2 sin 9 pi plus cos 9 pi. That is half into, what is sin at 9 pi? We know sin n pi equal to 0 for every n. And cos n pi is equal to minus 1 raised to n. You apply this result. So sin n pi is 0 plus cos 9 pi. You put n equal to 9. So minus 1 raised to 9. It is minus 1. So it is minus 1. So the answer is minus half. So f3 is minus half. So I2 becomes minus I pi. So we have I2. You put the values of I1 and I2 in equation number 1. So it is I pi minus I pi. It is 0. So the value of the integral is 0. Next you consider a similar question. Integral over c sin pi z square plus cos pi z square by z minus 1 into z minus 2, where c is mod z equal to 3. Now you can easily answer this question. Let me show it. First we notice the singularities. Clearly it is 1 and 2. Both are inside of c. So we have to start with the partial fraction. You give the partial fraction of 1 by z minus 1 into z minus 2. And it is given by, you will get the numerator of a by putting z equal to 1 here. Then it is minus 1. For getting b, you put z equal to 2 here. It is 1. Next you multiply both sides by sin pi z square plus cos pi z square. You take integral on both sides. Let it be I1 and I2. You consider equation number 1. Next we have to evaluate I1 and I2. Calculation of I1. For getting its value, you compare this integral with this integral. So for getting the answer, we have to identify Z0 and Fz. Clearly Z0 is 1 and Fz is minus sin pi z square plus cos pi z square. By Cauchy's integral formula, I1 is 2 pi I into f of Z0. That is 2 pi I into f of, here Z0 is 1. Next we have to find f of 1. It is minus sin pi plus cos pi. That is minus of sin pi 0, cos pi minus 1. So it is 1. So I1 is 2 pi I. So we have I1 equal to 2 pi I. Next we have to find I2. For evaluating I2, we have to keep Z0 as 2 and Fz as sin pi z square plus cos pi z square. By Cauchy's integral formula, I2 is 2 pi I into f of Z0. Here z naught is 2. So it is 2 pi I f of 2. So we have to find f2. It is sine. And z is 2. It is 4 pi. Similarly cos 4 pi. What is sine 4 pi? We know sine n pi is 0 for any n. Cos n pi is minus 1 raised to n. Here n is 1. So minus 1 raised to 4, it is 1. So f2 is 1. So I2 is 2 pi I. So we have both I1 and I2 are 2 pi I. Next we substitute I1 and I2 in equation number 1. So it is 2 pi I plus 2 pi I. So the answer is 4 pi I. See, this is the answer of the given integral. Next, we have to answer another question. Integral over c 4 minus 3 z by z into z minus 1. By looking into the function, clearly 0 and 1 are the singularities. With respect to mod z equal to 3 by 2, both are inside of c. Here, more than one singular point within c, so we have to start with the partial fraction. So the partial fraction of 1 by z into z minus 1 is, and the numerator of z is minus 1, numerator of z minus 1 is 1. So for making the given integral, you have to multiply throughout by 4 minus 3z. Next you integrate on both sides. You keep it as I1 and this integral as I2. Next we have to evaluate I1. So for evaluating I1 with respect to this Cauchy's integral formula, we have to choose Z0 and Fz properly. We have to evaluate this by using this equation. So by comparing these two integrals, you can take Z0 as 0. And Fz is minus 4 minus 3z. Then I1 is given by, what is I1? 2 pi I into f of z0. That is 2 pi I into f of 0. What is f of 0? f0 is minus 4. So minus 8 pi I. So this is our I1. Next we have to find I2. So for evaluating I2, you have to keep z0 as 1 and Fz as 4 minus 3z. Then I2 is given by 2 pi I f of z0. That is 2 pi I f of 1. F of 1 is again 1. So it is 2 pi I. So now we have the values of I1 and I2. You substitute in equation number 1, that is minus 8 pi I plus 2 pi I, that is minus 6 pi I. See, this is the answer of the given integral. Let me evaluate one more integral. Integral over c 5z plus 7 by z square plus 2z minus 3 dz. By looking into the given function, we can find its singular points by solving the denominator, and we can see its values are minus 3 and 1. So the singularities of the given function are minus 1 and 3. Clearly, minus 3 is outside and 1 is inside. Here, one singular point is within C. Only one singular point. So there is no need of giving partial fraction. We have to rewrite the given question by factorizing the denominator, and it is like this. Here only one singular point is within C and it is 1, so we can consider it as Z minus Z0. So you have to keep Z0 as 1, so you keep this function as Fz, that is 5Z plus 7 by Z plus 3. Now we can apply Cauchy's integral formula. And by Cauchy's integral formula, integral over C, f z by z minus z naught dz is 2 pi I into f of z naught. That is 2 pi I f of 1. Next, f1 is, you put z equal to 1. That is 12 by 4. That is 3. So it is 6 I pi. So the value of the given integral is 6 pi I.